Day 3, again, don't worry about what it says for what day it is. There are technically, I guess you could say, 4 main shortcuts for derivatives. Again, remember you saw the other day that big formula that was on there? That's actually doing it by the definition. These all can be done that way. Okay. And if I am here next year, then you will have to do some by the definition. And you're going to have to do some hard ones that way. Once you do that, I will refresh your memory of these shortcuts, and we'll go from there. Those of you that plan on going on, especially in mathematics, you might want to get used to seeing things written this way, because a lot of times that's what your textbooks are going to say. That's what's going to be written in there. And if you're having difficulty understanding the teacher, I mean, you're going to have to be able to look at this and figure it out. This right here is just basically means derivative, which means slope. You can see basically the delta has changed to a d instead of a triangle. That's about all that happens with derivatives. The dx means with respect to x, and really what it is 2 functions, and how are they attached right there in the middle? By multiplication, which is why this is called the product rule. Remember yesterday I said that little shortcut I showed you works as long as things aren't multiplied together. Okay? And what I'm going to have you do, I'm going to force you to do this one product rule. Because if you look at example 1, I could very easily foil that, correct? And then just do it like we did yesterday. You could do it that way. Product rule by itself is maybe not necessarily the most helpful of shortcuts, but when you bring in something else, it's hugely helpful and saves you a ton of time. So let's make sure we know product rule before we go on. Basically, does that one right there that I just underlined, does that have a prime on it? So is that going to be a derivative right there? Nope. How about the next one? Does this next one have a prime on it? Yeah, so basically what it's saying is just take whatever that first function is and write it down, and then take it times the derivative of the second function. The reason I'm saying second is g of x comes second and f of x comes first. And then it's saying plus. Let's look at that. Multiplication and addition going together yet again. Right? Same thing as logarithm, same thing as exponents and all that stuff. And then it's basically, is there a prime on that one? No, so it's basically saying write down the second one and take it times what? The derivative of the first one. But seeing there's plus in the middle, does it matter which way you do those? Not really. Basically what you're going to do is take one of them times the derivative of the other one and then flip-flop what you just did. I would try and follow some kind of formula if I were you. So let's try it. We took the derivative of the left side. There we go, f prime of x. So I would kind of consider this right here as being your f of x in this case. And that one over here is kind of like your g of x. Because are they multiplied together? Yeah, and that's when you're going to use product rule. So this little formula, and I probably didn't give myself enough room. I'll try and write kind of small. It says to take whatever the first one is and just do what to it? Yeah, just write it down, right? Okay. The first one written down is simply 3x minus 2x squared. Got it. Then it says to take it times g prime of x, which is derivative of the second one. So let's take a look. We got to take the derivative of that. Is that something we can do? Yeah, because if you just cover up f of x, that's something that we did yesterday, right? Using that simple power rule. What is the derivative of 5 plus 4x? Is 4. All right, well, that's pretty simple. What should be the next thing I should write down then? Plus. Very good, because plus comes next. And I pretty much always do it this way. Then I'll flip it around and I'll say, okay, let's write down the second one. And then times the derivative of the first one. I don't know why I put that parenthesis so close. We now have to take the derivative of the first one, which means take the derivative of this. Well, what's the derivative of 3x is 3, and then basically minus, be careful, 4x. Very good. So that right there, technically that's the derivative. If you gave me an x value that you wanted to know the slope at, I could substitute it in there. But what, remember I told you we're going to be setting this equal to stuff. Do we really want to set that stuff that we have in blue equal to something right at this point? Probably not. That's not very neat and clean, is it? Okay, and let's face it, we know that if we FOILed this out and took the derivative, it actually would be kind of straightforward, right? It wouldn't have been that complicated. So what you have to do is just clean it up then at this point. And so what can I do with this first portion here? Yeah, distribute. So what do we got? 12x, 8x squared, yeah. Plus, now unfortunately, what do we have to do with the second one? Yeah, we got to FOIL anyways. Now you just have to trust me at this point. I know that it seems silly. Why would we do product rule and then have to FOIL when we could have just FOILed and done it simply? I'm trying to get you to know product rule. So what do we got here? 15 minus 20x plus 12x careful x squared. So we got that one and that one that can be combined, right? What do you do with the coefficients if the exponents are the same? Yeah, you just add or subtract them, and so it's negative 24x squared. Very good. Those are done. Here's an x, here's an x, here's an x. If I was doing that, I'd add the 12 and the 12 together. That's 24, and then I'd subtract the 20. It's just the quickest way to do it. Plus 4x. Very good. Plus 15. And there it is. Remember, that's basically saying that if you knew what that original graph looked like, I could substitute any x value into this derivative and it would tell me the slope of that tangent line. Yes?
You went into like the way or like descending orders, 4x plus 5. You in the parentheses from your, or do they got to stay in the circle?
As far as foiling, as long as you have the correct sign on the correct term, you're basically taking everything times everything anyways. So it doesn't matter as long as you make sure you take everything times everything. It doesn't matter which order you do it. So that's where too many people get boiled down with the FOIL and they have to do it this way, have to do it, and that's not the case. At first glance, this does not look like it would be product rule because there is nothing actually multiplied together. Technically, it should be a division formula. There is one, which you will learn. That's called quotient rule. Funny how they come up with these names. But I'm going to show you a little trick that can be very helpful. I'm going to make that right there unhappy. And how do I make that unhappy? Well, I'm going to write a y. So am I taking the derivative right now based on what I just wrote down? No, I'm not taking the derivative right now. I'm just rewriting it. I agree that we have a 3x squared plus 5 on the top or in the numerator. Now be careful. What I'm going to show you is only going to work when it's a monomial on the bottom, meaning one term. If you have a binomial down there, meaning two terms, this doesn't work as well. You will learn how to do that, but it works very well if it's this way. That's a really bad plus. So I'm going to make it times x to what? Negative, I think one of you said it and one of you didn't, negative second power. Okay. So you could look at it as basically this is your first function right there for f of x, so the way we have it before, and that is your second one. There is actually a much quicker way to do this one. I'll show you that one in a second if you'd like to see that. But I want to work on product rule. So product rule says to write down the first one and take it times the derivative of the second one. Now be careful on this. A lot of people mess this one up. So negative 2, I agree with that. X to the negative third, down a power, or subtract 1. If you're at negative 2 and you subtract another one, you're at negative 3. Very good. Plus. And then x to the negative 2, you can just write it down. Times what? I didn't put a very big parenthesis there. Why? Yeah, it's just 6x, because you take 2 times 3, 6x. As far as this particular one goes, I'm not going to expect you to do all the simplifying that we'll need to do next year, but at least get started. This 3x squared plus 5, is that happy with where it's at right now? Yeah, that's on top. That has no problem with being there. All right. So we got a 3x squared plus 5. Has no issues whatsoever with being on top. Well, actually, how should we do this? Maybe I'll show you a different way. I'm going to show you a different way because I can. So just kind of scribble that out on your notes if you used pen. Let's just go ahead and distribute. Take negative 2x to the negative third times this. So what is negative 2, this one right here, times 3, negative 6x. Now what do? It's a negative third power here and a 2 power there. Very good. You add them, so it's a negative 1. Very good. Well, what's the next term? There's a lot of arrows up there now. Can you see what should come next? Well, yeah, basically you take negative 2 times that, so it's negative 10. And do we do anything with the x then? Yeah, you just pretty much write it down, right? Yeah. So I think that way is going to work a little bit better for you for right now. So let's do it that way. Plus, now this is the one I'm a little concerned about. Very good, 6x to the negative first. I was concerned what you would do with the power. Because this is x to the first and it's x to the negative 2. When you multiply the x's together, the exponents get added, which leaves you with that. Any observations at this point? Yes? Yeah, this is negative 6x to the negative first, and that's a positive 6x to the negative first, so they cancel, leaving me with, oh, this will be interesting to see what you do. This is just me checking your Algebra 2, Chapter 5 memories. Where does stuff go? What's happy, what's not? The x is unhappy, so where does it want to go? Well, what about the negative 10? Goes on the top, because what's really the exponent? It's to the first power, so that's fine. And if you want, we can come back to this one when we get done with the other ones, and I can show you a much quicker way of doing that one. Okay, the question was, can we just leave it as negative 10x to the negative 3? Once again, I would caution you, that's going to cause you problems later on, or perhaps next year. Get used to writing it so you can actually set it equal to something. Whenever you have class next year, yes. Now, let's face it, it'd be way quicker on this one just to do what? Distribute the 5x to the fourth, correct? So let's again work on our product rule. Why don't you try this one on your own right now, but show me the product rule, please. All right, let's see how you did. So once again, I kind of try and figure out, well, which is the first one and which is the second one, and so it kind of looks like that, first one and second one. So f prime of x. So we took the derivative of the left side. We're doing good. So now we got to go ahead and we got to say, okay, write down the first one. Times the derivative of the second one. Plus the second one times the derivative of the first one. Okay. And again, you're going to want to be able to clean it up. So let's just work on those algebra skills right now. Let's distribute this. What do we get? 80x to the fourth. Very good. And that's another reason I want to do them this way, to make sure you have that algebra down a little bit better. Plus x to the sixth. That's actually the one I was most concerned about right there. I wanted to see, were you going to tell me x to the sixth or x to the ninth? All right, that was the one I wanted to find out. So plus 20 x to the fourth plus 45 x to the sixth. Very good. Again, that's the next one I was worried about. Were you going to tell me to the sixth or to the eighth? So then you take a look. And you say, okay, the derivative of this side is very simple. There it is. And that one can go together. And that one and that one can actually go together. And if we do that, and you don't really necessarily have to go in descending order if you don't want to, but a lot of people like to stay in that pattern. That's up to you. But what do we got? 105x to the 6 plus 100x to the 4th. Yes. You could try and simplify, but then you'd only be able to factor it out. You can't divide by 5 because there's f prime of x that you'd have to divide by 5. Yes, you could definitely factor out even a 5x to the 4th. You could factor out if you wanted to. And eventually, that might not be a bad idea to have you work on that, but I was going to save that for next year. Yep. And that's the one thing that you never... One thing that you should never, ever agree to in calculus is a multiple choice test. Because there's 27 different ways, at least 27 different ways to write that derivative. And just because it's not the way, you'll do it your way and maybe your answer won't be there. So never ask for a multiple choice test in calculus. All right, I want you to, well, do we need to do this one? I think you probably got product rule down fairly well, don't you? Yeah, I can get to give you the answer to that one. Well, oh yeah, this is a different one than what you have. I'm changing it for my next class that I teach advanced math in.
So next
So this is not the one you have. I actually don't have the answer then to the one that you have. So.
Did you get 54x squared plus 32? I don't know.
So any questions in general about product rule?